Understanding the Java Return Keyword, December 11, 2022. Today, I am going to illustrate the syntactic usage of the Java Return Keyword with the example of a Java program that I created. It should be noted that the syntactic usage of the Java Return Keyword differs from that of the return keyword in programming languages such as C and C++. For instance, the statement return 0, which indicates successful execution, is permitted in the main function in C and C++, but not in method main in Java. This is because in C and C++, the default return type of the main function is int, but in Java, the return type of the method main must be declared void. Void methods cannot return a value, therefore the statement return 0 is not permitted in method main in Java. Nevertheless, it is possible to include the return keyword followed by a semicolon at the end of method main in a Java program. It is noted that in Java, the return keyword is typed at the end of the body of a method. If the return keyword is typed anywhere in between the statements of a method, the error unreachable code will occur. Though the return keyword is usually typed at the end of the body of non-void methods, it is also possible to type the return keyword immediately followed by a semicolon at the end of the body of void methods. This means that it is possible to type return at the end of the body of method main, despite method main being a void method. For void methods, return is generally omitted, as this statement causes no difference in the output of the program. Besides, except for predefined methods such as method main, most methods have to be manually defined, which means that it is necessary to define a method manually before typing the return keyword at the end of the method body. It is possible to define any method before and outside method main, but defining any method inside method main is not syntactically permitted. Next, I am going to expound the syntactic details of defining a method. The first step in defining a method is to type an access modifier. The access modifier may be public, private, protected, final, or even left unspecified, but the public access modifier is most commonly used for defining methods. Since abstract methods do not specify a body, the access modifier cannot be abstract. The second step in defining a method depends on the syntactic usage of this very method. As it is not permitted to make a static reference to any non-static method, it is suggested that the second step in defining a method should be to type the static non-access modifier. The second step in defining a method could also be to type the return type of the method. It is possible to declare the return type as any of the 8 primitive data types, namely Boolean, byte, char, short, int, long, float, double. If the static non-access modifier is typed, then declaring the return type would be the third step in defining a method. If the static non-access modifier is not typed, then the third type in defining a method should be to define the name of the method. After defining the name of the method, the fourth step in defining a method should be to type an opening parenthesis should be typed, followed by a list of parameters, and then sealed by closing parenthesis. These parameters within the pair of parentheses are known as formal parameters. The syntax of the list of parameters is the return data type followed by a variable name. There can be one or multiple parameters within the pair of parentheses. All the 4 steps above should be done to complete the method header. After the closing parenthesis, an opening curly bracket should be typed to begin the method body. Inside the method body, it is permitted to include as many statements as possible, as long as the code of the method does not exceed the 65,535 bytes limit. After all the statements are typed, it is possible to type the return keyword followed by a value that matches the return type of the method, and then followed by a semicolon. Additionally, the sequence of methods in a program does not matter regarding the output of the program. After defining a static non-void method, it is possible to invoke this very method in the body of method main. It is noted that the most common practice for invoking a static non-void method is to include this very method in a system.out.println statement. It is also possible to invoke a static void method in the body of method main by typing the name of this very method followed by a pair of parentheses and a semicolon. Though it is possible to define formal parameters within the pair of parentheses in a static void method, it seems that it is insignificant and irrelevant to pass actual parameters in a static void method in the body of method main. In this Java program, it is noted that the actual parameters in the statement static void method 111,222,333 are insignificant and irrelevant. Nevertheless, it is not permitted to invoke any non-static void method in the body of method main, as it is not permitted to make a static reference to non-static methods. Nevertheless, it is still possible to invoke non-static void methods in classes without method main by typing the name of this very method followed by a pair of parentheses and a semicolon. Additionally, it should be noted that regardless of being declared void or not, it is also possible to invoke a static or non-static method in the body of another non-static method, but it is not permitted to invoke a non-static method in the body of a static method. In this Java program, methods in which return types include all the primitive data types and 3 reference data types have been declared. For double, int, long, float, it is possible to use arithmetic operators between the values after the return keyword. For byte and short, typecasting is necessary when using the return keyword as well as passing actual parameters while invoking the methods. For Boolean, the logical operators and vertical bar are used between values after the return keyword. For char, concatenation is not syntactically permitted, but it is possible to convert char values to uppercase or lowercase. String concatenation is syntactically permitted and achieved by using addition operators between multiple string values. For arrays, and classes such as swing objects, it is syntactically possible to define methods with such formal parameters, and it is possible to invoke such methods in the body of method main by passing null as the actual parameter in the relevant methods. Additionally, for long and float, the suffixes l and f should be typed at the end of actual parameters instead of formal parameters. While defining methods, it is possible to achieve polymorphism, which is one of the 4 characteristics of object-oriented programming. In Java, there are 2 types of polymorphism, namely runtime polymorphism and compile-time polymorphism. Compile-time polymorphism is achieved by method overloading and operator overloading. Method overloading is achieved by defining multiple methods with different lists of parameters, but with the same name in the same class. In this Java program, there are 3 methods named method overloading, despite their different lists of parameters and return values. The first method overloading returns a double value, whereas the second returns a Boolean value, and the third returns a string value. Thus, it is possible to pass various actual parameters to the methods with the same name in method main. Some argue that method overloading is a form of syntactic sugar, while others do not. This Java program is an ultimate exercise regarding the Java return keyword. In my opinion, it is a suitable exercise for immediate programmers with some programming experience. The key points of this program are summarized below. Key points: public access modifier, static non-access modifier, return types, primitive and reference data types, and void formal parameters, actual parameters, method overloading. Import java.text.decimal format, import java.util.arrays, import javax.swing.frame, import javax.swing.joboption pane, public class return keyword, / static methods with double variables as formal parameters, public static double sum to AA. Double B, return a plus B, public static double difference to AA, double B, return A, B, public static double product to AA, double B, return a B, public static double quotient to AA, double B, return A, B, public static double sum 3 AA, double B, double C, return a plus B plus C, public static double difference 3 AA, double B, double C, return A, B, C, public static double product 3 AA, double B, double C, return a BC, public static double quotient 3 AA, double B, double C, return A, B, C, / static methods with int variables as formal parameters, public static int sum to int A, int B, return a plus B, public static int difference to int A, int B, return A, B, public static int product to int A, int B, return a B, public static int quotient to int A, int B, return A, B, public static int sum 3 int A, int B, int C, return a plus B plus C, public static int difference 3 int A, int B, int C, return A, B, C, public static int product 3 int A, int B, int C, return a BC, public static int quotient 3 int A, int B, int C, return A, B, C, / static methods with long variables as formal parameters, public static long sum to long A, long B, return a plus B, public static long difference to long A, long B, return A, B, public static long product to long A, long B, return a B, public static long quotient to long A, long B, return A, B. Public static long sum 3 long A, long B, long C. Return A plus B plus C. Public static long difference 3 long A, long B, long C. Return A, B, C. Public static long product 3 long A, long B, long C. Return A B C. Public static long quotient 3 long A, long B, long C. Return A, B, C. Static methods with float variables as formal parameters. Public static float sum 2 float A, float B. Return A plus B. Public static float difference 2 float A, float B. Return A, B. Public static float product 2 float A, float B. Return A B. Public static float quotient 2 float A, float B. Return A, B. Public static float sum 3 float A, float B, float C. Return A plus B plus C. Public static float difference 3 float A, float B, float C. Return A, B, C. Public static float product 3 float A, float B, float C. Return A B C. Public static float quotient 3 float A, float B, float C. Return A, B, C. Static methods with byte variables as formal parameters. Public static byte sum 2 byte A, byte B. Return byte A plus B. Public static byte difference 2 byte A, byte B. Return byte A, B. Public static byte product 2 byte A, byte B. Return byte A B. Public static byte quotient 2 byte A, byte B. Return byte A, B. Public static byte sum 3 byte A, byte B, byte C. Return byte A plus B plus C. Public static byte difference 3 byte A, byte B, byte C. Return byte A, B, C. Public static byte product 3 byte A, byte B, byte C. Return byte A B C. Public static byte quotient 3 byte A, byte B, byte C. Return byte A, B, C. Static methods with short variables as formal parameters. Public static short sum 2 short A, short B. Return short A plus B. Public static short difference 2 short A, short B. Return short A, B. Public static short product 2 short A, short B. Return short A B. Public static short quotient 2 short A, short B. Return short A, B. Public static short sum 3 short A, short B, short C. Return short A plus B plus C. Public static short difference 3 short A, short B, short C. Return short A, B, C. Public static short product 3 short A, short B, short C. Return short A B C. Public static short quotient 3 short A, short B, short C. Return short A, B, C. Static methods with Boolean variables as formal parameters. Public static Boolean and value 2 Boolean A, Boolean B. Return A B. Public static Boolean and value 3 Boolean A, Boolean B, Boolean C. Return A B C. Public static Boolean or value 2 Boolean A, Boolean B. Return A vertical bar B. Public static Boolean or value 3 Boolean A, Boolean B, Boolean C. Return a vertical bar B vertical bar C. Static methods with a char variable as a formal parameter. Public static char to lowercase char A, char B equals character dot to lowercase a, return B. Public static char to uppercase char A, char B equals character dot to uppercase a, return B. Static methods with string objects as formal parameters. Public static string concatenation to string A, string B. Return A plus B. Public static string concatenation 3 string A, string B, string C. Return A plus B plus C. Static methods with arrays as formal parameters. Public static int, array int method int, A. Return A. Public static double, array double method double, A. Return A. Static methods with swing objects as formal parameters. Public static frame method frame, return frame. Public static option pane method option pane, return option pane. Static overloading methods. Public static double method overloading double x, int y, float z, return x plus y plus z. Public static boolean method overloading boolean x, Boolean y, return x vertical bar y. Public static string method overloading string w, string x, string y, string z, return w plus x plus y plus z, / static void method, public static void method int x, int y, int z, system.out.println. This is a static void method, return, / non-static non-void methods, public double non-static non-void method a double x, system.out.println. This is the first non-static, non-void method, return x, public double non-static non-void method double y, system.out.println. This is the second non-static, non-void method, system.out.println non-static non-void method a111, return y, / non-static void methods, public void non-static void method a, system.out.println. This is the first non-static void method, return, public void non-static void method, non-static void method a, system.out.println. This is the second non-static void method, return, public static void main string, args, / this format returns a value with 8 decimal places, if necessary, decimal format equals new decimal format 0. Hash, / print the prompts and the double values of actual parameters passed, system.out.println the value of 12.34 plus 56.78. In method double sum 2 is plus format double sum 2 12.34, 56.78, system.out.println the value of 12.34 56.78. In method double difference 2 is plus format double difference 2 12.34, 56.78, system.out.println the value of 12.34 times 56.78. In method double product 2 is plus format double product 2 12.34, 56.78, system.out.println the value of 12.34 56.78. In method double quotient 2 is plus format double quotient 2 12.34, 56.78, system.out.println the value of 12.34 plus 56.78 plus 90.12. In method double sum 3 is plus format double sum 3 12.34, 56.78, 90.12, system.out.println the value of 12.34 56.78 90.12. In method double difference 3 is plus format double difference 3 12.34, 56.78, 90.12, system.out.println the value of 12.34 times 56.78 times 90.12. In method double product 3 is plus format double product 3 12.34, 56.78, 90.12, system.out.println the value of 12.34 56.78 90.12. In method double quotient 3 is plus format double quotient 3 12.34, 56.78, 90.12, / print the prompts and the int values of actual parameters passed, system.out.println the value of 123 plus 456. In method int sum 2 is plus int sum 2 123, 456, system.out.println the value of 123 456. In method int difference 2 is plus int difference 2 123, 456. System.out.println the value of 123 times 456. In method int product 2 is plus int product 2 123, 456. System.out.println the value of 123 456. In method int quotient 2 is plus int quotient 2 123, 456. System.out.println the value of 123 plus 456 plus 789. In method int sum 3 is plus int sum 3 123, 456, 789. System.out.println the value of 123 456 789. In method int difference 3 is plus int difference 3 123, 456, 789. System.out.println the value of 123 times 456 times 789. In method int product 3 is plus int product 3 123, 456, 789. System.out.println the value of 123/456/789. In method int quotient 3 is plus int quotient 3 123, 456, 789, / print the prompts and the long values of actual parameters passed. System.out.println the value of 12,345 liters plus 67,890 liters. In method long sum 2 is plus long sum 2 12,345 liters, 67,890 liters. System.out.println the value of 12,345 liters to 67,890 liters. In method long difference 2 is plus long difference 2 12,345 liters, 67,890 liters. System.out.println the value of 12,345 liters 67,890 liters. In method long product 2 is plus long product 2 12,345 liters, 67,890 liters. System.out.println the value of 12,345 liters / 67,890 liters. In method long quotient 2 is plus long quotient 2 12,345 liters, 67,890 liters. System.out.println the value of 12,345 liters plus 67,890 liters plus 56,789 liters. In method long sum 3 is plus long sum 3 12,345 liters, 67,890 liters, 56,789 liters. System.out.println the value of 12,345 liters to 67,890 liters 56,789 liters. In method long difference 3 is plus long difference 3 12,345 liters, 67,890 liters, 56,789 liters. System.out.println the value of 12,345 liters 67,890 liters 56,789 liters. In method long product 3 is plus long product 3 12,345 liters, 67,890 liters, 56,789 liters. System.out.println the value of 12,345 liters / 67,890 liters / 56,789 liters. In method long quotient 3 is plus long quotient 3 12,345 liters, 67,890 liters, 56,789 liters. / print the prompts and the float values of actual parameters passed. System.out.println the value of 123.4f plus 567.8f. In method float sum 2 is plus float sum 2 123.4f, 567.8f. System.out.println the value of 123.4f 567.8f. In method float difference 2 is plus float difference 2 123.4f, 567.8f. System.out.println the value of 123.4f 567.8f. In method float product 2 is plus float product 2 123.4f, 567.8f. System.out.println the value of 123.4f / 567.8f. In method float quotient 2 is plus float quotient 2 123.4f, 567.8f. System.out.println the value of 123.4f plus 567.8f plus 901.2f. In method float sum 3 is plus float sum 3 123.4f, 567.8f, 901.2f. System.out.println the value of 123.4f 567.8f 901.2f. In method float difference 3 is plus float difference 3 123.4f, 567.8f, 901.2f. System.out.println the value of 123.4f 567.8f 901.2f. In method float product 3 is plus float product 3 123.4f, 567.8f, 901.2f. System.out.println the value of 123.4f/567.8f/901.2f. In method float quotient 3 is plus float quotient 3 123.4f, 567.8f, 901.2f. / print the prompts and the byte values of actual parameters passed. System.out.println the value of 12 plus 34. In method byte sum2 is plus byte sum2, byte 12, byte 34. System.out.println the value of 1234. In method byte difference 2 is plus byte difference 2, byte 12, byte 34. System.out.println the value of 12 times 34. In method byte product 2 is plus byte product 2, byte 12, byte 34. System.out.println the value of 1234. In method byte quotient 2 is plus byte quotient 2, byte 12, byte 34. System.out.println the value of 12 plus 34 plus 56. In method byte sum 3 is plus byte sum 3, byte 12, byte 34, byte 56. System.out.println the value of 123456. In method byte difference 3 is plus byte difference 3, byte 12, byte 34, byte 56. System.out.println the value of 12 times 34 times 56. In method byte product 3 is plus byte product 3, byte 12, byte 34, byte 56. System.out.println the value of 12/34/56. In method byte quotient 3 is plus byte quotient 3, byte 12, byte 34, byte 56. / print the prompts and the short values of actual parameters passed. System.out.println the value of 12 plus 34. In method short sum 2 is plus short sum 2, short 12, short 34. System.out.println the value of 1234. In method short difference 2 is plus short difference 2, short 12, short 34. System.out.println the value of 12 times 34. In method short product 2 is plus short product 2, short 12, short 34. System.out.println the value of 1234. In method short quotient 2 is plus short quotient 2, short 12, short 34. System.out.println the value of 12 plus 34 plus 56. In method short sum 3 is plus short sum 3, short 12, short 34, short 56. System.out.println the value of 123456. In method short difference 3 is plus short difference 3, short 12, short 34, short 56. System.out.println the value of 12 times 34 times 56. In method short product 3 is plus short product 3, short 12, short 34, short 56. System.out.println the value of 12/34/56. In method short quotient 3 is plus short quotient 3, short 12, short 34, short 56. / print the prompts and the Boolean values of actual parameters passed. System.out.println the value of true, false. In method Boolean and value 2 is plus Boolean and value 2 true, false. System.out.println the value of false, true, false. In method Boolean and value 3 is plus Boolean and value 3 false, true, false. System.out.println the value of true, false. In method Boolean or value 2 is plus Boolean or value 2 true, false. System.out.println the value of false, true, false. In method Boolean or value 3 is plus Boolean or value 3 false, true, false. / print the prompts and the char values of actual parameters passed. System.out.println the value of d. In method char to lowercase is plus char to lowercase d. System.out.println the value of q. In method char to uppercase is plus char to uppercase q. / print the prompts for method overloading and values of actual parameters passed. System.out.println the value of 12.3,456,78.9. In method overloading is plus method overloading 12.3, 456, 78.9f. System.out.println the value of false, true. In method overloading is plus method overloading false, true, System.out.println the value of \this \method \is overloading in method overloading is plus method overloading this method is overloading invoke the methods with arrays as formal parameters. Array int method null, array double method null, invoke the methods with swing objects as formal parameters. Frame method null, option pane method null, invoke the static void method. Static void method 111, 222, 333, print the prompts and the string literals of actual parameters passed. System.out.println the value of program terminated in method string concatenation 2 is plus string concatenation 2 program terminated System.out.println the value of program is terminated in method string concatenation 3 is plus string concatenation 3 program is terminated